there. Okay, we're going to be talking about algebraic powers, or we also call them exponents. Yesterday, we mentioned that the word power, potencia, no poder, all right? That's how we translate that in Spanish, power, potencia. Okay, so today we're going to start adding powers, okay? What happens when I have the addition of several situations that contain powers? So let's imagine that I give you, well, we're going to be doing several problems separated to understand this. Okay, let's imagine that you are given x to the second, and they tell you that you are having another x to the second. What will you do?
Add the x and add the exponents.
So
Maybe it could be 4x's.
4x's, But what do you think will be the answer of this?
X and exponent 4.
Okay, actually, no. The answer for having a situation like this will be 2 times x to the second, because whenever I am adding algebraic powers with the same power, I just go and add the coefficients. They are called similar terms. So I can say that I can add similar terms only when they have the same variable with the same exponent. So when that happens, I'm going to go and add the coefficient. Okay, so for example, if I, in example number 2, have y to the 7 plus y to the 7 plus y to the 7, what do you think the answer will be?
3 times y to the 7.
That is right, 3 times y to the 7, because whenever I have the same variable with the same exponent, I only go and worry about adding the coefficients. Okay, the coefficients are the numbers located next to it, next to the variable. So for example here, if I tell you, solve this addition, and I give you this, what will you do?
Add the exponents and the variable.
Actually, again, no, because a to the second and a to the third cannot be added. They do not have exactly the same variable with exactly the same exponents. So the answer there will have to be me leaving the things they are, because these are not addable terms. These terms do not have the same exponent, so they cannot be added.
Teacher, is that a 4?
Where, honey?
In the number 2, it's because I don't know what it is.
It's a Y.
Ah.
Seriously, am I that bad? It's a Y. I was very proud about my Ys, you know? Okay. What about this one? What will you do if someone asks you to add a to the second plus b to the second? What will you do? Will you be able to add that?
Maybe you can put like a and v a close and a2.
But if you do that, you will be saying that the addition became a multiplication, because If you put the a to the second next to the b to the second without a sign in between, you are making something that was an addition, you made it became a multiplication, and you don't have indications for that. So no,
So
here,
you leave it like that.
exactly, you leave it like that because you can only add those that have same variable with same coefficient. Same variable with same exponent, sorry. So what about this one? What do you think we should do in a problem like this? Okay, let's say we have 5l to the third plus 3n to the fourth plus 2l to the third plus 2n to the fourth. What do you think we should do in this case?
You add the ones with the same exponent and the same variable.
Exactly. You can use a method that is called bubbles to identify which ones are addable to which ones. So the L to the thirds will be added to L to the thirds, while the N fourths will be added to the N fourths. So this is what you do. You worry about the coefficients, not about the variables, because you are adding them. So this is what you get as an answer. The 5 and the 2 are added, and you get 7 L to the third plus the 3 and the 2 are added, and you get 5 N to the fourth. And that is how far you can go, because L's and N's cannot be added. They are not similar. So there is where you stop. Okay? Is everybody following what we are saying? The same will happen if you had something like this. Oh. Okay, let me see if I can undo this. There. Okay, 6. X to the second, -7, y to the second, +12, z to the second, plus 2x to the second, plus 5y to the second, plus 6z to the second. What do you think you should do here? Someone?
The bubble method.
The bubble method again, that is right, because you can only add similars. So x's to the second will be added with x's to the second. Y's to the second will be added with y to the second. And z's to the second will be added with z's to the second. Only the ones with equal variables and equal exponents can be added. You cannot mix. So the answer is going to be you adding of the x's to the second, you get a 3x to the second. So this one is the one you're going to put, this one. And then of the 7y's to the second, you have a -7y to the second and a +5y to the second. The addition of a negative and a positive, it's you subtract and keep the sign of the biggest. Do you remember that? Do you remember that rule? You subtract and keep the sign of the biggest whenever you have an addition of one negative and one positive. And then of the yellow ones, you have 12z to the second plus 6z to the second. That is going to make 18 z to the second. So you don't leave them like that. You have to put them in the form of an equation. Oh, I'm sorry. Let me see what I can do here. Is your teacher having fun? Okay, perfect. So at the end, you have to put all this in the form of an equation. So you are going to put 3x to the second minus 2y to the second positive 18z to the second. Another one. The variables can be combined, but even if they are combined, you can only add those that are considered similars. So, for example, here, we could have, I'm sorry about all this. I don't think you see what I'm going through here, but okay. Let's hope it works.
Teacher,
Yes.
so the 3x2 minus 2y2 plus 18c2 is the answer?
Yes, that's the answer because you have to put your answer in the form of an equation.
Oh, okay, thank you.
Okay, new example. We have to be very careful here. My example is here and below.
Even though like different, even though like the 2 and the 6, like even, yeah, the 2 and the 6 are different, even, but if the x and the y and everything are the same, we can still add them.
Only if it has the same variables with the same exponents. So here,
But the other number doesn't matter if it's
Teacher,
different.
can you scroll up a little bit, please?
there.
Yeah, that's good. Thank you.
Okay, here, if you check my equation number 7, let me see if I can separate it a little bit. No, they are together.
Sure.
Yes.
Is the answer 28 x to the second y?
No, because there is a slight difference between my terms. One has the y to the second power and the other one has the x to the second power. So here also the method of the bubbles is necessary. This one is going to be added with this one because it's x, y to the second. Meanwhile, this one is going to be added with this one because it is x to the second y. It is not the same to have the first letter taken to the second power than the second one. So even though these equations seem to have all the terms similar, they are not. The greens are similars, the blues are similars, but they are not similars between themselves. So at the end, you're going to end up having 10xy to the second plus 16xy, x to the second y. And that is how far you can go. because even though they seem very similar, they are very different. You cannot add them more.
Teacher, I didn't understand that part.
Okay, my terms are not similar. One of them is xy to the second, and then the other one is 6xy to the, x to the second y. So if you see, in some cases, the second power is over the y, and in other cases, the second power is over the x. So that's why they seem to be the same, but they are not. So we need to be very careful with these details, because similar terms are only those terms that have exactly the same variables with exactly the same exponents. So the moment you change one a little bit, stops being similar. Okay?
Okay, thank you, teacher.
So that will be the answer of number 7. In some problems in Alex, you will find that the instruction changes. Instead of saying add the similar terms, it says expand. When that happens, it's very easy. You just need to keep in mind that whenever we have a variable with a power, is related to having that variable several times. So, for example, if it says, please expand this problem, what will you do? How would you expand c to the 10th power?
C times C times C times C times C times C.
Exactly. C times C times C times C times C times C times.
Are like exponents.
It's like if all of them were having a 1, and then at the end, they became a 10. So expanding a 10th power is like having the multiplication of all the little variables taken to the first power. In the same way, if it says expand, with black. If it says expand and x to the second, y to the second, what do you think you should do?
X times y times y.
That is right. All of them multiply each other, so y is x times y times y. I'm gonna do my y's like this so they don't criticize my y's. Okay, what about if it says expand something like this? How will you expand it? 20.
Teacher,
Yes,
sorry if I interrupt you, but you're like trabando a lot, so can I change my internet?
sure. But is it me or is it you?
No, it's me, it's me, it's me.
Okay. Okay, how will we expand this one?
24C times 24C times 24C times.
Actually, no, ma'am. Be careful. The one that has an exponent is the c and the x. The 24 doesn't, so the 24 appears only once. The ones that repeat are the letters, but not the 24. The 24 appears in there only once. Okay, so if the 24 had also an exponent, then it will be repeated, like the example that is coming. In an example like this, the 5 should also be repeated because the 5 also has been exposed to having an exponent. So you are going to end up having 5x times 5x times 5x. So be very careful. If the power only affects the variable, the exponent doesn't repeat. But if the power also affects the coefficient, then the coefficient also repeats. All this is going to make sense better when we start tomorrow with what we call the rules of exponents. Tomorrow, you and I, we're going to spend a while dealing.
Teacher, the class already finished.
No, ma'am, 10:50. Camila, turn on your camera. Okay, let us do a few more. We still have time.
Teacher, sorry, I confused.
Yeah, I know. That happens when we have lunch before during the classes, you know? Does it sound familiar to you? Okay, here we go. So, what about having this one? Y7 what will you do to expand it?
y7 times y7 times y7 times y7 times y7 times y7, and then you go to the x, I believe there are 3, and then to the c that are 2.
Actually, no.
I think that it's not y7, it would be y1.
Exactly. You make it repeat 7 times.
But with a 1.
But with a 1 as an exponent. We're going to see the rules tomorrow. Because if you put y7 times y7 7 times, then you're going to alter the number. It's going to become 49 as an exponent. We're going to see all those rules tomorrow. So no, you only put it to the first power here. And then times x times x times x times z times c. You are expanding. This is, you are breaking into smaller pieces.
Teacher,
Yes.
why is y1 but x like doesn't have a number?
Even if it doesn't, they are taken to the first power. You can write it or not, it's optional. Listen, some of you have left the room. What if I call the roll again, you know? What will happen if I did that? Those of you gone will have an absentee. So I'm gonna let you all go right now to enjoy your recess time, but please let your friends know that they need to stay until the end, or I'm gonna start calling the roll twice per class, okay?
Yes.
Oh, teacher, sorry that I went, but instead of clicking to erase, I clicked to shut down. So that's why, but I give you again.
Okay, you can leave now. Have an amazing recess.
Thank you.
Bye.
Bye, teacher. Thank you.
Bye-bye, take care.
Bye.
Bye.
Oh my God.
Hi, Marta.
I'm sorry. I left the session
worries.
open all recess. I was doing something with a girl. I'm leaving. Sorry.
No worries. Bye. Have a good day.
Hi, nice to see you. I miss you.
I know. Well, take care. Good luck. Bye.
Bye.